Hello, in this video I would like to explain what is the Coulomb's law and what is the relationship between electrostatic forces that two particle charges can exert to each other, their distance and the magnitude of those charges. Before that, you should understand how we can make a particle charge. You can make a particle charge, a negatively charged particle actually, by adding some electrons to a neutral particle. If you add some electrons to a neutral particle, that particle will converge to a negatively charged particle. Similarly, if you take out some electrons from a neutral particle, that charge will convert to positively charged particle. The charged particles create an electric field at their surroundings. Around them, the space is different. There is some property in the space. That is because of electric field. We show the electric fields around a particle charge by some virtual lines that you can see here. They extend out from the positive charge and toward the negatively charged particles. So the direction of these electric fields are important. And the space after placing one positive charge and negative charge beside each other is like this. As I said, you cannot see these lines. They are virtual lines to show how the electric fields behave at the surrounding of these two charges. If you put two charges with the same sign, positive positive or negative negative, the electric field lines will form like this. Now, what is the Coulomb's law equation? In 1785, the French scientist Mr. Coulomb he ran some experiments by electric charges. He realized that if you place charge Q1 and charge Q2 at a distance r from each other, the forces that exert to these two particle charges can be calculated by this equation that says magnitude of electrostatic force here is equivalent to K, that is a constant number, charge number 1, actually magnitude of charge number 1, magnitude of charge number 2, regardless of what is their signs, and the square of the distance between these two charges. What is K? K is electrostatic constant or Coulomb constant. That is equivalent to 1 over 4 pi epsilon 0. That is an important constant, 8.99 times 10 to the power 9, and epsilon 0 is the permittivity constant. The unit of electric charge is Coulomb. Now, what happens? You can actually calculate the magnitude of electrostatic force using that formula. But how about the direction? If you put two positive charges close to each other, they will exert the forces F and F. They are exactly the same but in opposite direction. So they move these two charges away. Actually, these two charges with the same signs will repel each other. Same thing happens if you have two negative charge particles. They will repel each other because the signs were the same. But if you have a positive and negative, they will attract each other. So you can calculate the magnitude of electrostatic force between two particle charges using the Coulomb's law equation. But for the direction, you should consider the sign of these two charges. And based on that, determine the direction of forces. In upcoming videos, I will solve more examples and problems with some values and numbers. Just be careful that we can use this equation when we have particle charges. If there is a distribution of charge on the surface or in the space, there is more complicated equations that I will explain it in next videos. Now, how the charges will move in the electric field. So if I place a positive charge close to the positively charged particle at the left side, and I place a negative charge beside the negatively charged particle at the right side, as you know, the electric field around positive and negative charges are like this. These are electric fields. They extend out from the positive toward the negative charge. But in which direction the positive and negative charges will move? You know that the forces between positive and positive is repulsion. And it is an attraction between positive and negative and positive, the blue one. So the charges will move along the positive charges will move along the direction of electric field, and negative charge particle will move in the opposite direction of electric field. This is a very easy concept, but very important and essential. So, like every other positive charge particles, a single particle in the space, it creates an electric field around itself. You can define a potential, electrical potential. So this positive charge will move from higher electrical potential to the lower electrical potential. Please don't mix this up with the gravitational potential. However, this is a potential, but it is electrical potential. And for the positive charge particles, it moves from higher potential to lower potential. In this course, we use the positive 1 Coulomb as a test charge. And whenever you want to determine the direction of electric field, because you are not able to see these electric field lines, so if you just put a positive charge beside a particle to determine what is the direction of electric fields, just monitor the movement of that test charge, that positive charge. The direction that the positive test charge moves determines the direction of electric field for you in the space. Now, if you have a constant uniform electric field in a piece of space, in a part of space, when I say uniform electric field, it means the direction is constant. The magnitude of electric field is constant in that part of space, and the lines are parallel. The electric field lines are parallel. And the density of electric field lines is the same everywhere. In the left side, I have potential V1, and in the right side, I have electrical potential V2. Can you tell me which potential is greater? Yes, V1 is greater than V2, because if I release a positive charge at the left side, it will drift or speed up toward the right side. And for electrons, this scenario is inverse. They will move from V2 to V1. But to don't confuse you, we always consider the positive charges. So the direction of movement for positive charges determines the direction of electric field for you. I hope you understand the main concept of electric charges, the Coulomb's law, electric field, and potential. In next videos, I will explain more about the relationships between electric field and electrostatic field, and also electrical potential.